So let's talk about electron configuration. Now, each element on the periodic table has their own code to describe the electrons they have. Now, the code that the elements have is called electron configuration, which represents the arrangement of electrons in an orbital. The electron configuration reflects the following information about an element. Tells us the type of our orbital, the number of electrons, and the main energy level that those electrons have. Okay, so here's a periodic table. Now, when we do these electron configurations, we always got to start with hydrogen. Also, here's kind of a notation of how it looks, but we're going to talk more about that as we do an example. So let's go ahead and do an example. Let's go ahead and find the electron configuration for sodium. Now, like I said before, we have to start at hydrogen. So we got to start with the block that hydrogen's in. Well, hydrogen is an S block, so we got to start with that block row. What I mean by block row is the either S block in that row, or P block in that row, D block in that row, F block in that row. So hydrogen is in the first row in the S block with helium. Okay, so we're going to do that first. Now, like I said before, hydrogen and helium are in the same block. Now, is sodium in that first block row, in that S block first row? No. So we have a total of 2 elements in that first row block. So when we start off our electron configuration, we do 1, which represents the row, the orbital block it's in, which is S, and how many elements there are, which is 2. And that 2 has to be subscript, has to be a small number on top. Now this is where kind of this notation comes in. Remember our quantum number, our principal quantum number, that's represented N, and that tells us the row the element's in. Well, whenever we get to S block, it's just going to be the number, the row number it is. So we have 1s2, first row, S block, 2 elements, 1, 2. So let's go ahead and move on to our next row block, which is lithium and beryllium. Lithium and beryllium are both in the S block, and they are in row 2. Now, is sodium in that row block? No. So there's a total of 2 electrons. Since we are in the S block, the second row, and there's 2 elements, our continuation of the electron configuration is 2s2. 2 represents the row, S represents the block, and the subscript 2 represents how many elements there are. So we have 2s2. Now we got to move on because we're not at sodium yet. Now, like reading like a book, going from left to right, we go ahead and jump to boron, carbon, nitrogen, oxygen, fluorine, and neon. And that row is again 2, but we're not in S anymore, we're in P. So this is a new row block. We're in 2P. Row 2, block P. Now, is sodium in this row block? No. So we have a total of 6 elements. Since we are in row 2, block P, and there's 6 elements, to continue the electron configuration, we got 2P subscript 6. Because we're in the second row, we're in P block, and there's 6 elements. We're still not at sodium yet, so we got to continue. Now we're in row 3, and we're in the S block now. So our row block is 3P, row 3, block P. Now, is sodium in this? Yes. So we count the number of elements till the element we want. So we won. So we're in row 3, block S, and 1 element till we get to sodium, until it's sodium. So to end the electron configuration, we do 3 for the row, S for the block, and 1 for the element, because it takes us 1 to get to sodium. So your final electron configuration for sodium is 1s2, 2s2, 2p6, and 3s1. Okay. Alrighty, so let's go ahead and do another example. Now we got iron. Okay. So again, we always have to start at hydrogen. So our first row block involves hydrogen, helium. We know that's row 1, and since iron is not in that row block, we got a total of 2 electrons. So to start off with this electron configuration, we do 1s2. 1 for the row, s is the block, and there's 2 elements in that. Let's go ahead and continue on like reading a book. This is our next row block. It's in row 2 and has lithium and beryllium, and we're in the s block still. So we have 2s, row 2, block s. Now is iron in this row block? No, so we have a total of 2 electrons. So to continue on our electron configuration, we have row 2, block s, and 2 elements, so 2s2. We're still not at iron, so we got to continue on. So we got our p block, and we're still in the row 2, so our row block is 2p. So is iron in this row block? No. So we have a total of 6 elements. So our continuation of our electron configuration is 2p6. We're in row 2, block p, and there's 6 elements. We got to continue on since we're still not at iron. Our next row block is the third row, and it's s block. So we have 3s. And is iron in this row block? No, we have a total of 2 then. So our continuation for our electron configuration is 3s2. It's because we're in row 3, we're in the s block, and there's 2 elements. And we still got to continue on. So our next row block is we got our p block, still in row 3, so our row block is 3p since we're in the third row and we're in the p block. Is iron in 3p? No, so our total number of elements is 6. And since we're in a third row, p block, and there's 6 elements, our continuation for our electron configuration is 3p6. We're still not at iron, so we got to continue on to our next row block, which is here. That's s block, and we're in the 4th row. So our next row block is 4s. Now is iron in this 4s? No, so we have a total of 2 elements. Since we're in the 4th row, the s block, and there's 2 elements, we continue our electron configuration to 4s2. Now we got to move on to our next row block. Now we're getting into something we haven't seen before. Now we're at D block. Remember D block that we learned yesterday. Now, for D block, we're still in row 4, okay? And is iron in this row block? Yes. So we have to count up until we get to iron. 1, 2, 3, 4, 5, 6. Now, a lot of you guys want to say, okay, so then our continuation is going to, since we're in row 4, we're in the D block and there's 6, it's going to be 4d6. That's wrong. This is where this notation comes in handy, because once you get to D and F, you take that row number, your n, minus 1 for D. Since we're at 4, row 4, so we got to do 4 minus 1. So the next notation is 3d6, not 4d6. 3d6. Let's go ahead and do, so our final electron configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d6. Let's go ahead and do another example. Let's go ahead and find the electron configuration for silver. Again, we always have to start at hydrogen. So our first row block involves the s block. We are in the first row. So our first row block is 1s. Silver is not in this row block, so there's a total of 2 elements. So the start of our electron configuration is 1s2. Now we got to continue on to our next block, which is s. And we're in the second row, so our row block is 2s. Silver's not in this row block, so we have a total of 2 elements. Since we're in row 2, block S, and there's 2 elements. We continue on our electron configuration with 2s2. We got to move on. Our next block is P. We're still in the second row, so our row block is 2p. Silver is not in this row, so we have a total of 6 elements. Since we are in the second row, the P block, and there's 6 elements, our continuation is 2p6. We got to continue on. So our next block is S. We are in the third row, and silver is not in this row block, 3s. So we have a total of 2 elements. Since we're in the third row, the S block, and there's 2 elements, our continuation is 3s2. We got to continue on. We're back at P block. We're still in row 3, and silver's not in this row block, so we have a total of 6 elements. Since we're in row 3, block P, and there's 6 elements, we continue on with 3p6. We got to continue on. Now we're back at S block, but this time we're in row 4. Silver's not in this row block, so we have a total of 2 elements. Since we are in row 4, block S, and there's 2 elements, we have 4s2. Now we got to continue on to our next block. Now we're at D block. Still in the 4th row, and silver is not in this row block, so we got a total of 10 elements. Now, remember, it's not 4D10. We got to subtract 1 to our row number. Since our row number is 4, we do 4 minus 1, so that 4 becomes a 3, so we actually have 3D10. So now we got to continue on, and we're back at P. Now this row block is still in row 4. Silver's not in this row block, so we got 6. So we're in row 4, block P, and there's 6 of them. We got 4p6. Continuing on, we got row 5. We're in S block, and silver's not in here, so we have 2 of them. So we continue on to say it's 5s2. Now we move on to D block again. This D block is still in row 5. Is silver in this row block? Yes. So we count up until we get to silver, which is 9. And a lot of you guys would want to do, okay, since we're in row 5, we're in D block, and there's 9 elements to get to silver, I'm going to say it's 5D9. No. Remember, we got to do our row number minus 1. Since our row is 5, we do 5 minus 1, which is 4. So it's actually 4D9. Let's go ahead and do one more example. Now this time we got tungsten. We're going to go all the way to tungsten. Again, we start with hydrogen. We're in S block. We're in row 1. Tungsten's nowhere near here, so we have a total of 2. So we got 1s2. Then let's continue on. We're still in S. We're in row 2. There's 2 elements. So we got 2s2. Continue on to P block. We're still in row 2. Tungsten's not here, so we got 6 elements. So we have 2p6. Continuing on, we're in S block again. We're in row 3. Tungsten is not here. We got 2 elements. So we have 3s2. Back to P block. Still in the 3rd row. Tungsten's not here, so we got a total of 6 elements. So it's 3p6. Going back to S block, but this time we're in the 4th row. Tungsten is not here, so we have 2 elements. So it's 4s2. Now we start with D block. We're still in row 4. Tungsten's not here. We got a total of 10. But since we can't do 4D10, we have to subtract that row number by 1. So it's 3D10. Continuing on to P. We're still in the 4th row. Tungsten's not here, so we have 6 elements. So we have 4p6. Continuing on, we are at S block again, but we're in row 5. Tungsten's not here, so we have a total of 2, so it's 5s2. Moving on to another D block, still in row 5. Tungsten's not here, we have a total of 10 elements. It's not 5D10. Remember, we had to subtract the row number by 1, so it's 4D10. back to P, fifth row, tungsten's not here, so it's 6 elements, so it's 5d6. Going back to S block, now we're in the 6th row. There's 2 elements because tungsten's not here, so we continue on to 6s2. Now, a lot of you guys are going to want to jump to D block. No, remember that these 2 inserts over here. So we got to move down to our F block. Now we're at our F block, okay? That F block is still in the 6th row. Tungsten's not here, so we got to total up all of our elements, which is 14. Now, a lot of you guys are going to want to say, okay, since I'm in the 6th row, I'm in the 6th row, I'm in F block, there's 14. Okay, it's 6F14. No. Now, this time, we got to take our row number minus 2. So 6 minus 2 is 4, so it's actually 4F14. We're still not at tungsten, so we got to continue on. Now we're at our D block now. We're still in the 6th row. Tungsten's in this row block, finally. So counting up to tungsten is 1, 2, 3, 4. A lot of you guys are going to want to say, it's okay, well, it's 64. No, because remember, when we're at D, we got to subtract 1 to the row number. So 6 minus 1 is 5d4. Alrighty, that's our final electron configuration. So I want you guys to do these examples on your own. So you're going to write the electron configuration for the following elements. So do it for mercury. Here's your answer. Now do it for zirconium. Here's your answer. Now do it for calcium. And here's your answer. Now do it for holmium. And here's your answer. Alrighty, so now these electron configurations can also be written shorthanded by using the noble gases. Now the noble gases are all the elements in group 18 of the periodic table. It's the very last group in the periodic table. And when you write these electron configuration, instead of starting at hydrogen, you're going to start at the back closest noble gas. So remember, you're going to start at the back, back nearest noble gas. And so the noble gases are right here. They are all in the group 18. And also, I'm going to put this notation here again. So let's go ahead and do some examples of these shorthanded notations of electron configuration. Let's do it for magnesium. Now, instead of starting hydrogen, we got to start the back most noble gas. So moving back, it's actually neon. So we're going to start an electron configuration with neon. You'll put neon symbol with brackets around it. So kind of looking like this. And then you just continue on. So we're in the S block. We're in row 3. Magnesium is in this row block. So we count up to magnesium, 1, 2. Since we're in row 3, the S block, and there's 2 elements, we do 3 S2. And that's the shorthand electron notation. All right, let's move on. Let's do another one. Again, we got our noble gases highlighted. And let's go ahead and do the shorthand electron configuration for zinc. Now we got to backtrack to our closest noble gas, which is argon. So we're going to start with argon symbol or surrounded with brackets, and we continue on from argon. We're in S block. We're in row 4. Zinc's not in this row block, so we have a total of 2 elements. So we have 4s2. We got to continue on because we're not at zinc yet. We move on to our D block. We're still in row 4. but zinc is in this row block, so we count all the way up to zinc, which is 10. And a lot of you guys want to do 4D10, but remember, if we're in D block, we got to take our row number minus 1. So 4 minus 1 is 3, so it's 3D10. Let's do another example. Let's go ahead and find the shorthanded electron configuration for cerium. So remember, this insert is right here, so we're in row 6. So backtracking, we're going to start with the noble gas of xenon. Remember, symbol of xenon with brackets around it, and then we'll continue on to S block, row 6. Cerium is not in this row block, so we have 2 elements. So we go 6s2. Then we continue on to our F, because remember, for row 6 and 7, we do S, then F block, then D, then P. So we're still in row 6, we're in F block, and cerium is in this row block, so we count up to that element, which is 2. Now, a lot of you guys just want to say 6F2, but we're in F block, so we take the row number minus 2. So 6 minus 2 is 4, so it's actually 4F2. Let's go ahead and do one last example. Let's go platinum. So backtracking to the back closest noble gas, which is xenon. So we start off with xenon symbol in brackets. Then we go ahead to do our next block. We're in S block, we're in row 6. Platinum's not in this row block, so we have total 2 elements. So we say 6s2. Then we go down to our F block. Now we're still in row 6, but platinum is not in this row block, so we have a total of 14 elements. So a lot of you guys want to say 6F2, but that's not correct because we have to take our row number minus 2 if we're going for our F block. So 6 minus 2 is 4, so we have 4F14. Then we go back up to our D block. Now platinum is in D block. This D block is in row 6, and platinum is in this row block. So we count all the way up till we get to platinum, and that's 8. Now a lot of you guys are going to want to say 6D8, but since we're in D block, we got to do row number minus 1. So 6 minus 1 is 5, so it's 5D8. Alrighty. So I want you guys to do these following examples on your own. So you're going to write the short-handed electron configuration, not regular electron configuration, short-handed, so with noble gases for the following elements. We got nickel. And here's your answer. Try it for sulfur. And here's your answer. Now try it for, can't even say that element, but that element. And here's your answer. And then go for uranium. And here's your answer. And that's it. Thanks, everyone.